Okay, this is the third part of the series about section R3, which is R5, which is factoring. This is the example we just worked in the second video, and we talked about if the leading coefficient, the coefficient of the x squared term, is 1, then you can use trinomial factoring that involves figuring out what two numbers multiply to give you the constant, but that add together to give you the coefficient of x. Okay, and I'm going to work another example right here. I guess I probably should have mentioned what is a trinomial. A trinomial is a polynomial with 3 terms. So we're always looking for a polynomial with 3 terms if we're going to do trinomial factoring. Okay, it does have a 1 in front. So that allows me to use this process. I want to know what two numbers will multiply to give me 24, but that will add together to give me negative 11. So anyway, I'm just going to play dumb here and say, okay, I'm going to try 1 times 24. Does 1 plus 24 equal 11? And I think it's pretty obvious that is a big no. Now, noticing that this needs to equal negative 11, maybe I should try negative numbers. And once again, if I put negative 1 and negative 24, because negative times negative equals positive, you'll still see that it doesn't come up to the negative 11 I'm trying to get. Okay. So if I think a little more on it, I think I can probably come up with the fact that a negative 3 and a negative 8. How's that for a couple that give me positive 24 when I multiply? But what are they when I add them together? Well, negative 3 plus negative 8 is going to be negative 11. And that's what we were looking for, negative 11. I now know my two numbers that I'm going to put in my parentheses with my x. And the reason I'm just putting just plain x's is because this was 1x squared, and so it has to be 1x and 1x. Alright, my two numbers were negative 3 and negative 8, so I'll write those in there. And there we go. So it's pretty simple. You figure out what numbers multiply to give you the constant, but that add to give you the coefficient of x. And remember, to use this process, it has to be trinomial, and the coefficient of x squared has to be 1. Okay, now I'm going back to the previous page in the notes so we can talk about what if it doesn't have a 1 in front. Well, there's an actual process for that, and it's similar to the other. So I like that. I like the fact that it's going to be similar to the other one, but it's a little more complicated, which of course I guess it should be. It's not a 1 in front. Okay, here's the rule. First thing we're going to do is we're going to multiply a times c. So the coefficient of x squared we will multiply by the constant. So you find that product. You multiply them two together. After you do that, you do the same process we did above, except for you're saying what two numbers multiplied will give me that product. For example, if I did a times c and got 24, I'd say what times what equals 24. So don't just say what times what equals c. What times what equals the product of a and c. That's where we take care of that number that wasn't a 1 in the front. Then we've got to make sure that the two numbers we're multiplying to get that number is also going to add together to give me the middle term, just like we did before. So that's what I like about this process, is it's very similar to the previous process. After you find the two numbers, we're not in as good of luck as we was with the previous, where you just wrote parentheses and wrote x plus whatever that number is. Now you have to rewrite the original trinomial, this a squared plus bx plus c, where you replace the bx with x terms that have coefficients of the two numbers you found. Okay? And then use factor it using grouping, which we did previously. So I'm going to do some examples, that way you can see what I'm talking about. Okay, on the first example you see we don't have a coefficient of 1. So the process said first step is to multiply A times C. So A times C is 2 times 6, which is going to give me 12. Okay, so 12 is the number we're looking for. What numbers will multiply to give me 12, but also add to give me 13? I'm going to put a question mark here because, you know, who knows. Okay, well, I think 1 and 12, right? Positive 1 and positive 12, if you multiply, give you 12. And if I add them two, you see it comes up to 13. So, 1 and 12 are going to be my numbers. Now, it's said on the, I guess it was probably the third step. I don't have the study guide right in front of me. 2x squared, and then we will put, we're going to replace the 13x with plus 1x and 12x. That's the two numbers that I got from over here. And plus 6. Alright, first pair. I can divide out of x. Now we're doing the grouping thing, in case you're wondering. 2x plus 1. I want to get a 2x plus 1 from the next pair. Well, which one will I get the 2x from? It'll be 12x. What would I have to divide 12x by to get a 2x? A positive 6. So I put plus 6. When I divide 6 out of both of these, I'm going to get 2x right here. And I divide 6 by 6, I get positive 1. I have similar factors here, which is what we wanted. So the common factor is 2x plus 1. And what is 2x plus 1 being multiplied by? Well, x and positive 6. And that's it. It's that easy. Okay, I'm going to quickly do the next two. 4 times negative 6 is negative 24. Here, I'll write that down. 4 times negative 6. So I want to know what times what is negative 24. Well, it could be 1 and 24, but that's not going to give me 5 when I try to add it, because remember we're trying to add to get 5. 2 and 12, no. 3 and 8. Now 3 and 8 will work if I use negative 3 and positive 8. And that's going to work nicely for my signs here too. When we're multiplying the negative times the positive, it gives me a negative. So negative 3 plus positive 8 will equal 5. So these are my two numbers, negative 3 and positive 8. I replace the x term with negative 3x and 8x. Make sure you put the x's on there, because if you don't...
Just FYI, teachers, Mr. Drummond's best.
Sorry about that, I'm making the recording at school. Okay, anyway, first pair you can divide out of x. On the second pair, you can divide out of 2. And what do the two have in common? Well, they have a common factor of 4x minus 3. And what is 4x minus 3 being multiplied by? Looks like x plus 2. Okay, I think I'm going to stop at this point because I'm about to run out of time on this video. On the next video, I will do the next examples, and I'll show you the special cases where there's shortcuts where you don't have to rack your brain so much. Hopefully.